Welcome to today's Explainer. We're jumping right into a truly mind-bending thought experiment today. We're going to explore the visceral, physical reality of what would actually happen if we doubled the size of our home planet. We often think that having more space would just magically solve all of humanity's problems. But as we unpack the data today, you're going to see that a supersized Earth actually comes with relentless, chaotic weather and a totally crushing physical toll on the human body.
Picture this for a second. What would happen if you woke up tomorrow morning, stretched in your bed, and suddenly found that the Earth you live on was twice as big? Would your life just go on as normal, maybe just with a lot more real estate out your window? Or would the fundamental rules of your everyday existence completely change? Let's keep that question in the back of our minds as we dive into the numbers.
It's so easy to fall into that bigger is better trap, right? We assume a larger planet just means more room for activities. But the geometry of expanding a sphere is incredibly deceptive. If we double the diameter of Earth, we don't just double everything else. No, we end up with a planet that has 4 times the surface area, jumping from about 510 million square kilometers to over 2 billion square kilometers. And assuming the planet's density stays the same, we are looking at an absolutely astounding 8 times the mass.
Section 1. The Mega-Earth Math.
So, looking at the numbers, this math cascades into a very serious physical problem for us. We've got our 2 times increase in diameter, taking us to over 25,000 kilometers wide. We have our 4 times increase in surface area. But that 8 times increase in mass, that is the real kicker here. Because of how physics works, multiplying the mass by 8 on a planet with twice the radius means that our surface gravity effectively doubles. That's right. Everything on this new mega-Earth suddenly weighs twice as much as it did yesterday.
Section 2. The Crucible, a denser, thicker atmosphere.
Here's a crucial point to remember. Gravity doesn't just pull you down, it pulls the sky down too. A stronger gravitational pull holds onto a lot more gases, keeping them from escaping into space. This means our new Earth is going to develop a much denser atmosphere. And according to the source material, this change could raise our oxygen levels significantly, potentially jumping all the way up to a massive 25%.
We're basically moving from our normal, breathable atmosphere into an environment with noticeably higher pressure. Honestly, breathing this thicker air would feel almost like inhaling a heavy liquid, thick and totally overwhelming in your lungs. But here's a wild side effect of that 25% oxygen environment. Just like in prehistoric times, higher oxygen levels could actually support much larger organisms. Yep, we are talking about the potential for giant insects. It's a fascinating, if maybe a little creepy, evolutionary consequence of just having thicker air.
Section 3. Extreme weather and climate.
So we've got a clear, terrifying chain reaction going on here. Step 1, that stronger, doubled gravity locks in more gas. Step 2, we get that denser, heavier atmosphere we just talked about. And step 3, that thick atmosphere acts as a hypercharged engine for relentless extreme storms. We are talking torrential rainfall capable of rapidly drowning landscapes. Plus, because we have 4 times the surface area, climate variations become incredibly extreme. We'd see violently shifting seasons, way larger deserts, and incredibly vast rainforests. The weather on this doubled Earth would essentially be a chaotic, destructive force.
Now, with those massive global weather changes raging all around us, I want to ask a very relatable question. Could your body even survive the morning commute?
Section 4. Crushing gravity on humans.
Literally, your body is suddenly fighting a war against the planet itself. The cardiovascular strain would be immediate. Your heart has to pump twice as hard just to force that thick blood up to your brain. Then there's massive musculoskeletal stress. Your bones and joints are suddenly supporting double your body weight. On top of all that, you face respiratory difficulties. Because of that thicker, heavier atmosphere, the physical act of just expanding your lungs against the pressure is significantly harder, totally altering how your body absorbs oxygen.
This creates a frankly horrifying daily reality. The sheer heavy exhaustion of just trying to walk, to breathe, or even just sitting up to get out of bed would be monumental. Simple tasks like lifting a cup of coffee or taking a single step require massive amounts of energy because everything is twice as heavy. The source points out that moving around would require so much extra effort that our basic daily activities and even how we work would have to drastically change just to accommodate this bone-deep fatigue.
And hey, if you think you could just sleep it off, think again. The massive increase in the planet's mass could actually alter our rotational speed, likely slowing the Earth's spin. This means we're no longer looking at a standard 24-hour day. A slower rotation means longer days and longer nights. This would completely disrupt our circadian rhythms and sleep patterns, piling chronic biological fatigue right on top of the physical exhaustion of fighting double gravity all day.
Section 5. How we might evolve. To actually survive this intense cardiovascular strain and that crushing 2 times gravity, the human body would eventually be forced into evolutionary adaptation. Over many, many generations, humans would likely evolve away from our current tall, lean forms. Instead, we develop a physique built for sheer endurance, thicker bones, denser muscles, a much more compact frame. These changes would be absolutely essential just to withstand that constant downward pull.
Which brings us to a really fascinating, kind of bizarre contradiction highlighted in our source material. The quote reads, "With more space, humanity might spread out in ways that seem completely unbelievable today. We've got an entire planet with 4 times the surface area, virtually limitless new continents, deeper oceans, totally uncharted territories. But the reality? We are practically glued to the floor by gravity, exhausted by simply walking. It's the ultimate irony, right? Endless room to explore, but a body that struggles to even take the first step."
But as the source notes, before we can even think about exploring those unbelievable new horizons or building massive new architectural wonders, the human body would experience immense strain. Unlocking this new world requires incredible biological resilience first. We'd have to engineer completely new ways of transportation, totally rethink agriculture for heavier crops, and completely redesign our infrastructure from the ground up just to survive the baseline environment of our very own home.
So, what do you think? Would you actually survive the crushing gravity, the constant physical exhaustion, and the hypercharged storms, all for a chance to explore a massive, practically limitless Earth? It's a pretty profound question about human resilience and our drive to explore against all odds. I hope this thought experiment expanded your mind today, just as much as our hypothetical planet expanded its mass. Thank you so much for joining me for this explainer, and keep questioning the world around you.